Okay, the problem that we are solving now is for EDM Logarithmic Models, the mastery test, question 1. And in this one, it's talking about sound, and specifically how we measure sound, which is in decibels. The scale for measuring sound is a logarithmic scale, and this is the equation representing that scale, okay? And this here, this beta, it's like a B with a long arm here. This is the decibels that we would be measuring, okay? Beta. Okay, so sound in decibels is beta. I is the intensity of the sound measured, okay? And then I initial is the smallest intensity heard by the human ear, and it gives us this. This is the given information, okay? So all that we would need to do is plug this in for I initial here. And this specific problem is asking about the difference between an air conditioner and a washing machine and how their sound intensity differs. So it's asking basically for a ratio of the two. We're going to solve for both of them and figure out what is the actual intensity of a washing machine sound versus the intensity of an air conditioning sound. Okay, and then all we do is divide them, and we find out how much more times greater is that washing machine to the air conditioner. This is a logarithmic scale, right? So even though it says that the washing machine gives out a sound of 65 decibels, whereas the air conditioner is 50 decibels, that is not a linear model. We're going to find that the washing machine is much, much, much louder on the linear scale, okay? So we're going to go ahead and do the math to prove it. So all I did here is I'm going to start with the washing machine. The washing machine has a sound of 65 decibels. So I plug in for my beta, 65, and I made sure to plug in my I initial of 1 times 10 to the negative 12. I'm going to explain, if you don't know what that means, I'm going to explain that in a little bit. So we're just doing algebra here. We divide both sides by 10. And then here's where the log comes into play. Anytime we see a log without a base, it means that base is 10, okay? So log base is 10. So here's what we do. We do this like switcheroo little move, okay? Now to get rid of our log, we put our base down. So our base is 10. We take the left side, move it into the exponent of that base, and we take what's under the log and we put it on the left side here. So now we just have a regular equation. So 10 to the 6.5 power, we just plug that into the calculator, and you're getting about 3 million, okay? And then all we're doing is multiplying both sides by 1 times 10 to the negative 12. So 1 times 10 to the negative 12 is scientific notation. This is what the actual value is, okay? It's a bit ridiculous to have to write out this whole huge number, okay? Which is why we use scientific notation, because in science, we're often dealing with very, very large values or very, very small values. And this one is the latter. You can see that the decimal is way over here, and we have something in the, far, far over here past the decimal, which is a very small number, okay? But it is still significant. So all we do here is multiply both sides by that scientific notation of 1 times 10 to the negative 12. And this is the value that we get for the intensity of a washing machine. Okay, that's watts per meter squared, 3.16 times 10 to the negative 6 in scientific notation. Okay, now we're going to do the same thing for the air conditioner. The air conditioner is 50 decibels. I'm not kind of showing you along on this one just because it's the same exact thing. We're just using 50. As we go through, we end up with this intensity, 1 times 10 to the negative 7th watts per meter squared. So to figure out how much larger the washing machine is to the air conditioner, you just divide the two answers and you get 31.6. So a washing machine is 31.6 times louder than an air conditioning. There you have it.